Good morning, calculus students. So Mr. Chen again. So this one today I would like to talk about approximating elementary functions with polynomial. So this one is coming out from the Rogowski textbook 8.4 or the one by Larson, so section 9.7. So using the first order polynomial, so p of x, to approximate the functions f of x, e to the power of x, center at x equals c equals 0. So normally the linear approximation formula, so going back to what we did before in Cal AB, it's always consider f prime of c times x minus c plus f of c. So the way that we did it is like natural log, not natural log, it's L of x, linear approximation, or f prime of a, x minus a plus f of a. So this one is quite similar. So instead of using a, we're using c. So for the first one, so let's find out the first derivative. So e to the power of x, derivative would be e to the power of x again. So f prime of 0, so that would be e to the power of 0, so which is 1. So using that, the linear approximation formula, which is considered like p of x, so for that, f prime of c, so that would be 1 times x minus 0 plus f of 0. So it's 1 times x, which is 1x. F of 0, so that just e to the power of 0. It's also 1. It's the same function, so it's x plus 1. So this one gives you the first order of the polynomial for the approximating that e to the power of x. And now let's look at that the graph right here. So e to the power of x, so it's exponential growth model. And then for that linear functions, x plus 1, it's just y equals x plus 1. So the y-intercept, which is 1, right up here. And then the slope, 1 over 1, so 1 up, 1 over to the right. So it's pretty close for the approximation. And now the other one, so we want to use the second order. So the second order is similar to what we found there. So it's always consider, well, the first one it's f of c, then the second one would be consider the first derivative f prime of c, x minus c, and then the second one would be f double prime of c, and then x minus c, quantity square. And also putting the order, this one is the 0 order, this one is 1 because the power, and this one is the second order, so it's 2 factorial. So using that approximation, so based on what we found from the previous one, x plus 1, and then second derivative, so for f double prime of x is also e to the power of x. So the value of c is 0, so f double prime of 0, it's also 0. It's 1. So that one, so it's 1 again, over 2 factorial. So 2 factorial, that would be 2, 1/2. And then x minus c, so x minus 0, so it's x quantity to the power of 2. So 1/2 x squared. And this one you can always rearrange the order from least to the greatest, so it's 1 plus x plus 1/2 x squared. And now, so once we finish that, okay, so this one also you can look at the graph. So it's the quadratic functions. So just make the graph with the vertex, all that. You'll see that it's getting close with that e to the power of x. So now this time we need a better approximation. So let's try the third order. So the third order, based on what we found, 1 plus x plus 1/2 x squared. So the third order would be considered f triple prime of c, x minus c to the power of 3, all over 3 factorial. As you can see that c is 0, so x to the power of 3, so that would be the variable to the power. So third derivative, so e to the power of x, the third derivative would be e to the power of x. So e to the power of 0, that's just 1. 3 factorial, that's 6. So this one is written as 1 plus x plus 1/2 x squared plus 1 over 6, and then x to the power of 3. So also this one would be the cubic curve. You can just make the graph and see how close they are. So looking at the calculator there, so the third approximation, so 1 plus x plus 1/2 x let's clear all this. Clear all this. Okay, so start with the original function, so e to the power of x. And then for the third order polynomial, we got 1 plus x plus 1 over 2 x squared, the second order. And then the third order, so let's go back to what we have right here, which is 1/6 times x to the power of 3 okay, so 1/6 plus x to the power of 3. Okay, so go to zoom standard. Okay, so this will give you the better view. As you can see that this part of the graph here, it's almost overlapping. So the cubic approximation, the third order. And now let's see what else that we have. So approximating an elementary function with polynomial. So the general form for the polynomial, it's always written as 1 plus x over 1 factorial plus x squared over 2 factorial plus x to the power of 3 over 3 factorial. And then the pattern here, recursive formula, x to the power of n minus 2 over n minus 2 factorial, x to the power of n minus 1 factorial to the power of n factorial, like that. So this one is saying that the value of c got to be 0. So that would be the simplest form. So the definition of the nth Maclaurin polynomial and the nth Taylor polynomial, the comparison. So the one that we just did with the value of c equals 0. Okay, so if the value of c equals 0, from that the Taylor polynomial, so this one is just go back to the Maclaurin polynomial. So the Taylor polynomial normally is being generated f of c plus f prime of c x minus c. So it's pretty much the same thing here. Okay, so pretty much the same thing. And then f double prime of c x minus c quantity squared over 2 factorial. So find the third Taylor polynomial for f of x equals sine of x. Expand about c equals power of 6. So using that, the Taylor polynomial, so started off with f prime of x. So we got cosine of x. Okay, so you want to find out that f prime of pi over 6. So cosine of pi over 6, cosine of 30 degree. So that would be root 3 over 2. Okay, so using that, the third Taylor polynomial. So find out second derivative as well. So negative sine of x. So f double prime of pi over 6. So negative sine of pi over 6. So negative 1/2. And then triple prime. So negative cosine of x. So f triple prime of pi over 6. So that would be negative root 3 over 2. So using the formula, so this one, it's considered the third one. So p sub 3 of x with that sine of x approximation. So this one will be written as f of c. So f of c, so f of c, so sine of pi over 6, which is 1/2. Okay, so 1/2 plus f prime of c, we found it already, root 3 over 2, and then x minus c, so x minus pi over 6, and then the second one, f double prime of c, which is negative 1/2, so minus 1/2. Over 2 factorial. So over 2 factorial, that means you divide it by 2, so it's going to be 1/4. Try to simplify it a little bit. And then x minus pi over 6, because c is pi over 6. Quantity square. And then the third one, finally, triple prime of c, so negative root 3 over 2. Okay, so minus, well, got to be careful with this one here. So sine, derivative of that, it's cosine, but it's negative. Okay, so minus root 3 over 2, but 3 factorial, so that's 6. So So it's root 3 over 12. Okay. And let's see what else. So x minus pi over 6 quantity to the power of 3. As you can see that the power here, so it's just been increasing. So pi over 6 to the first power, x minus pi over 6 to the second power, x minus pi over 6 to the third power. But the first term is always the constant, 1/2. Okay, so the constant, so f of pi over 6. So sine of pi over 6, 1/2. Okay, so the third order of the Taylor polynomial approximation for sine of x at the center of pi over 6. Okay, so any questions that you have, feel free to put into the YouTube channel comment bar. Okay, so I'll try to reply that as soon as possible. So thank you for watching the video today. So make sure that you guys recognize this two type of formula. So one is just the general polynomial with the Maclaurin, and the other one it's the Taylor. Okay, if c is not 0. Alright, see you next time.